Okay, so now we're going to do a lesson on the derivatives of logs and exponentials. We're going to start off with exponentials. Okay, so a basic exponential expression would be y equals, or f of x equals a to the x, where a is some number greater than 1. Okay. For an exercise, I want you to try and work out the limit that you see here. The limit as x goes to infinity of 1 plus 1 over x, all to the power x. Now the only way you can really do this is by subbing in some numbers. Okay, so if you've tried this, so you pause the video, give it a try, and now if you come back, check to see if you got the right answer. So it should be about 2.718. Now on your calculator, you'll see a button that's called e to the x. You should see a button called e to the x on your scientific calculator. If you hit that button and then you hit 1 as the x, you should get a number that's very close to this. So this number is called the exponential number. It's very convenient because it shows up in math all the time, okay, and in nature too. And you can look that up, the exponential number. Okay. Another limit I want you to try, now that we know this number e, and you know where it is on your calculator, is this one. So the limit as h goes to 0 of e to the h minus 1 all over h. Okay, so I'll pause the video, give that a try. Okay, now you've come back and you're going to check to see if you get the right answer, and it should be 1. Okay, so these two limits, well, this one here, this number, and then this limit with that number is going to make calculus quite easy. Okay, so any exponential function, so y equals a to the x, so if that's 2 to the x or 3 to the x or whatever, you can write that as any other number, 3 to the x. Okay, so you can use any base. For example, 2 to the x equals 3 to the, say, y. So if I choose a number for x, there is a y value here that makes that equal. So 2 to the 2 equals 4, obviously, and 3 to the something will equal 4. Okay, so we can write any exponential function in terms of any base. So say you have 2 to the x, and you want to write it with a base of 3. Well, that is going to be 3 to the b. Okay, so 3 to some exponent b will make that a 2. Okay, so there is an exponent b that makes 3 to the b 2. And if 3 to the b, so 2 equals 3 to the b, okay, 2 equals 3 to the b, then 2 to the x equals 3 to the b to the x, okay, which equals 3 to the bx. So you could change from a base of 2 to a base of 3 as long as you have some number here in front of x that makes 3 to that exponent equal to 2. Okay. So we're going to now look at f of x equals e to the x. So we're going to use this base here. This is an irrational number. We're going to use this base, and we're going to look at the derivative. So the derivative is this expression. The limit as h goes to 0 of f of x plus h minus f of x all over h. Using some of our exponent rules, we can break that down. Okay, so you know that the product with the same base, you add the exponents, or you go backwards and you break the exponents up. Now you can factor out an e to the x. Okay. this makes life really easy, because you see that this piece right here is this limit. So we can use our limit rules by distributing the limit in. This doesn't have an h in it, so it's treated like a constant. Okay, and you know that this limit here equals 1. So 1 times e to the x is just e to the x. And we now have, well, we can write that as exp of x if you like the sine and cosine notation of a function. Okay. So the derivative of e to the x is e to the x. That is really convenient. Okay, so the derivative of e to the x is itself. So the slope of the tangents of e to the x are itself. So when you look at an exponential function, okay, it goes like that. It always goes through 1. So if you look at the value of that at, I don't know, say 3. So e to the 3 is some y value. So e to the 3. Okay. The slope of the tangent here is that value, no matter where you go. So at 1, so e to the 0 is 1. The slope of the tangent there is 1, always, in every exponential function with base e. Okay, so we have to look at other exponential functions soon, but first we're going to look at an example. Okay, so let's look at the example here of e to the 2x. Okay, so the derivative, remember this is a way to write this function, exp of 2x. So we got to remember the chain rule when we're doing this. So the derivative of e to the 2x is the derivative of the outside, which is the derivative of the exponential function. And that is just 2x. So the derivative of the outside is itself. And then times the derivative of the inside, which is the derivative of the exponent, which is 2. Okay, so this is the other way of writing it. And one way to think about this is it's the derivative, you rewrite the whole function, if it's an exponential function, and then multiply it by the derivative of the exponent. Okay, so for example, if you had f of x, if you had y equals e to the f of x, then y primed is always going to be f primed of x e to the f of x. Okay, so the derivative of the exponent times the function again. Okay, let's look at what else here. Let's try this example right here. So f of x equals e to the x squared. So the derivative of x squared is 2x, and then you write the function again. Okay. The inside of this function is x squared. A lot of people want to bring down this exponent and then subtract 1. They want to bring down the x squared and then subtract 1, x squared minus 1. That is incorrect, because this e is not the variable. Okay, so you can't do that because that's not the variable.